Today's lesson is about L'Hopital's rule. L'Hopital is a way that you can evaluate indeterminate limits. When the ratio of two functions tends to 0 over 0 or infinity over infinity in the limit, such forms are said to be indeterminate. So that is something you've already learned. The new stuff is down here. Limits of the indeterminate forms, 0 over 0 or infinity over infinity, may be evaluated using L'Hopital's rule. L'Hopital's rule is a method for finding limits that initially equal 0 over 0 or infinity over infinity. And here's how you would use L'Hopital's rule. If you have a limit in indeterminate form, which means you have 0 over 0 or infinity over infinity, then all you need to do is take the derivative of the numerator and take the derivative of the denominator separately and reevaluate the limit. L'Hopital's rule says that the limit as x approaches a of f of x divided by g of x is equal to the limit as x approaches a of f prime of x divided by g prime of x. But a very important note is that this is only true if you had indeterminate form. Back in Unit 1, when we were working with the limits, to evaluate a limit, we first tried direct substitution. So if you want to solve the limit as x approaches 3 of x squared minus 2x minus 3 all over x minus 3, we first try substituting x is equal to 3 in for all the x's. That would give us 3 squared minus 2 times 3 minus 3 all over 3 minus 3. 3 squared is 9. 9 minus 6 is 3, and then 3 minus 3 is 0. And then in the denominator, 3 minus 3 is 0. So for this, we get 0 over 0. So I'm going to go back to the original limit. And you might notice that the numerator can be factored. If we factor the numerator, that would factor to x minus 3 times x plus 1. Now that we have a common factor of x minus 3 in the numerator and in the denominator, those will cancel out. And our limit reduces to the limit as x approaches 3 of x plus 1. We could try direct substitution again. Substituting 3 in for the x, we would have 3 plus 1, which is equal to 4. The new way of evaluating this limit, using L'Hopital, starts the same way as the old way. We first want to try direct substitution. Plug the 3 in everywhere you see an x, and then only if we find that the limit is indeterminate can we use L'Hopital's rule. And take the derivative of the numerator and the denominator separately. The derivative of x squared minus 2x minus 3 would be 2x minus 2, and the derivative of the denominator is equal to 1. Now we can try direct substitution again. Substituting in 3 for x, we would have 2 times 3 minus 2 all over 1, which would equal 4. Here's a few things to keep in mind when you're evaluating limits that involve a 0 or infinity. Indeterminate form is only when you get 0 over 0 or infinity over infinity. These are the only two situations where you can apply L'Hopital's rule. If you evaluate a limit through direct substitution and you find that you get 0 over some number, that means your answer is just 0, so you would not use L'Hopital's rule. If you evaluate your limit and you get a number divided by 0, that is equal to either positive infinity or negative infinity, because you really don't have a 0 in the bottom. You just have a number that's really, really close to 0. And any fixed number divided by a very, very tiny number that's infinitely small, that whole fraction would blow up to infinity or negative infinity. If you have infinity divided by a fixed number, that would equal infinity. And finally, if you have a fixed number divided by infinity, that would equal 0.